Today we're going to be looking at a second difference between inequalities and equations. But before we go over this, let's have a short exploration. Take a look at the table here, and we're going to go through it together. We have inequalities here listed on the left. We're going to say whether they're true or false. We're going to do something to both sides, write a new inequality, and then decide if it's still true or false. So starting with the first one, 1 is less than 4. That, of course, is true. If I add 2 to each side, okay, it should stay the same. So, the same relationship. So 1 plus 2 is 3. 4 plus 2 is 6. And so this is still true. So you can see if I add 2 to both sides of this inequality, it still remains true. Let's try it with the next example. This time, though, we're going to subtract 2 from both sides. So I'm going to subtract 2. Negative 4 minus 2 is negative 6. 6 minus 2 is 4. Negative 6 is less than 4. So that's still true. It was true in the beginning, and it's still true. Okay, now let's see what happens if we multiply both sides by 2. So I'm going to multiply both sides of this inequality by 2, which 2 is less than 4. So from the beginning, we know that it's true. If I multiply 2 times 2, I'm going to get 4. On the other side, if I multiply 4 times 2, I'm going to get 8, and 4 is less than 8, so that's still true. Let's take a look at the next example. We have negative 10 is less than 10. Okay? All negatives are less than all positives, so we're going to say that this is true. But this time we're going to multiply each side by a negative, and by a negative 2. So instead of that positive 2, we're going to try to see what happens when we multiply by a negative 2. So on my left side, I have negative 2 times negative 10, so that's going to give me positive 20. On the right side, I'm going to have 10 times negative 2, so that's going to give me negative 20. Our symbol is less than. And now I want you to take a look at this statement. This statement is saying that 20 is less than negative 20. That's false. So you can see when we multiplied each side by that negative 2, it caused it to be false. So in order to write this correctly, we would then say, we would have to flip the sign, and we would have to say that 20 is actually greater than negative 20. When we multiplied by that negative 2, it reversed the relationship. Let's look at the next example. What if we divide? What if we divide by 2? So we're going to divide both sides of this one. And negative 8 is less than negative 4. So we're going to say from the beginning that this is true. And if I divide them both, negative 8 divided by 2 is negative 4. Negative 4 divided by 2 is negative 2. We had the less than sign. Negative 4, is it less than negative 2? Yes, it is. This is true. So when we divide by that 2, the inequality is still true. Now let's try and see what happens when we divide each side by a negative 2. First of all, negative 12 is less than negative 10. That is true, because negative 12 is more negative than negative 10. But now let's take a look and see what happens when I divide each of these by a negative 2. Negative 12 divided by negative 2 is positive 6. Negative 10 divided by negative 2 is positive 5. The inequality sign that we had here was less than. So notice what happened here. 6 is less than 5. Is that true or false? Of course, that is false. So in order to make this inequality true, we would need to flip the sign, and instead of 6 is less than 5, we would say 6 is greater than 5. So I want you to notice when we multiplied or divided each side of the inequality by a negative number, it caused the relationship to change, and we had to flip our sign. And this is the second difference with inequalities. And it has to do with sometimes you have to flip the sign. So whenever you multiply or divide, as we saw in our example, both sides of an equality by a negative number, you must flip the inequality sign. An easy way to remember this, if the coefficient the number with the variable is negative, you're going to flip the sign. So for example, if I have negative 4x is greater than 8, I'm going to flip it. Because you have a negative 4 next to the variable, you have a negative number. It's also true when you're dividing by a negative number, when the variable has been divided by a negative number. So if I had x divided by negative 4 is greater than 8, the number that I'm dividing the variable by is negative, so this is also going to be a flip. And you'll see in the examples why this matters. So let's look at a couple of examples. Okay, we have the first one here. We have 10 minus 4x is greater than or equal to negative 10. Okay, just like with equations, we're going to put our line down the middle. And we're going to take a look at what we have here. I have 10 minus 4x. I have my variable on the right side. Let's make this a little smaller. So I'm going to undo what's been done. So the first thing I'm going to do is I'm going to get rid of this positive 10 by subtracting 10 from both sides. Okay, I subtracted 10 from both sides, so it cancels out on the left, and then on the right side I have negative 10 minus 10, which is negative 20. My inequality symbol stays the same. I subtracted 10. And then remember, you got to bring down negative 4x. Because you're subtracting 4x from 10, you have to bring down the negative as well. So now notice what we have here. I have a negative number next to the variable. So this means negative 4 times x is greater than or equal to negative 20. So I'm going to need to divide by a negative 4 in order to do the next step in solving this inequality. And just like we saw in the examples before, whenever I divide by a negative number, the relationship between the two sides of the inequality is going to flip. So I'm going to flip down here, just to remind myself I need to flip the symbol. So instead of greater than or less than, it's going to be less than or equal to. So on the left side, negative 4 divided by negative 4 is 1. So I'm just left with x. And then on the right side, I have negative 20 divided by negative 4, which is 5. So again, we flipped the symbol on this one. Because I divided right here, you can see that I divided both sides by a negative. Now let's go ahead and graph it. If I have x is less than or equal to 5, that means a solution is 5. So 5 is a possible solution. And I'm looking for numbers that are less than or equal to. So I'm going to draw my arrow to the left. And based on this graph, I can come up with 3 possible solutions. I could come up with way more than 3 solutions, but here I know that 5 is a solution because it's greater than or equal to. Another solution from this number line would be 2. Another would be 1/2, right? Because 1/2 is between 0 and 1. So anything to the left of 5, including 5, would be a possible solution. Let's look at a few more examples. Okay, we have another example here. We have 3x minus 5 is less than 11. So I'm going to put my line down here. I have my variable on the left side. And so what I'm going to do here is I'm going to undo what's been done, 3 times x minus 5, by adding 5 to both sides first. I'm adding 5, nothing's flipping. I'm adding a positive 5. So my negative 5 and positive 5 are equal to 0. So that's going to cancel out. I have my 3x is less than negative 11 plus 5 is negative 6. Okay. Now let's take a look at the side with our variable. It has a coefficient of 3. So it's 3 times x is less than negative 6. Now in order to find the value of x, I'm going to have to divide both sides by 3. Okay? Now this negative 6 is negative, but I'm dividing both sides by 3. Because I'm dividing both sides by a positive number, this is going to leave the symbol alone. We're not going to flip our inequality sign. So we're just going to continue. 3 divided by 3 is 1. So we're going to bring down our x. And then negative 6 divided by 3 is negative 2. And so our solution to this inequality is going to be x is less than negative 2. And again, we didn't flip because this was a positive number. If we had divided by a negative, we would have to flip. But since we were dividing by a positive, we don't. Let's go ahead and graph this. Okay, this is a x is less than negative 2. So that means it couldn't be negative 2. So when it can't be negative 2, if negative 2 is not a part of the solution set, we're going to use an open circle. And we're going to look for all of the numbers that are less than negative 2 on our number line. And now from this I can pick out 3 possible solutions. Okay, this time negative 2 is not a possible solution because I have this open circle. Negative 2.5 would be, right? Because negative 2.5 would be right here between negative 2 and negative 3. See, another one would be negative 3, negative 5. Anything to the left of the negative 2 would be a solution. All right, let's look at a third example. Okay, we're going to put our line down here. Let's check it out. Oh, our variable is on the left again. And what we're going to need to do is undo what's been done to x so that we can get our solution, just like we did with equations. So the first thing you should notice here is that we have a positive 4 minus 3/4 times x is less than 8. So the first thing I'm going to do is I'm going to get rid of this positive 4. So I'm going to subtract 4 from both sides. Now I'm subtracting 4. Yes, I see a negative because subtracting 4 is like adding negative 4. But we don't flip the sign when we add or subtract. So nothing to do here yet. But the 4 minus 4 is 0. That's going to cancel out. On the right side, I have negative 8 minus 4, which is negative 12. And then I'm going to bring down my 3/4 x, but notice that this was minus 3/4 x. So I need to bring down my negative sign. And our inequality is still less than so far. All right, now I want you guys to take a look at what is next to that variable right here. Our coefficient, the number that's next to the variable, is negative. And since the coefficient is negative, that means in order to solve it, we're going to multiply by the negative reciprocal. So here, to solve this, I'm actually going to have to, let's move this over a little bit. I'm going to have to multiply by a negative number. to get rid of a negative. So I'm going to multiply both sides by the reciprocal of 3/4, which is negative, or the reciprocal of negative 3/4, which is negative 4/3. And I have to do it to both sides. Okay? So now we've multiplied by a negative number, both sides. So that means we're going to have to flip our symbol. So instead of less than now, our relationship is going to be greater than. On the left side, we know when we multiply by the reciprocal, this is equal to 1. Negative 4/3 times negative 3/4 is equal to 1. So we have now just x. And then on the other side, we have negative 12 times negative 4/3. Let's bring in our calculator for that, just to make sure. So I'm going to multiply negative 12 times negative 4/3, negative 12 times negative, fraction key. I'm going to put in my 4/3, and then that's my answer. My answer is 16. Again, I just took this part of the inequality on the right. Because I multiplied by a negative, that's why I flipped my sign. And then the number I'm going to write on the right side is 16. Because x is greater than 16. Going to our number line, we have a greater than sign, so that means if x is greater than 16, that means it can't be 16. It's anything greater than 16. X is greater than 16. So I'm going to be looking for values that are to the right of the 16, not including the 16. Because it's an open circle, because this is greater than, we would close it if it was greater than or equal to. So 16 is not a solution, 17 is a solution, 19 is a solution. Notice that our arrow continues infinitely, so we could even say 100 is a solution. Okay, today we have learned the second difference in inequalities, and that is you are going to flip the inequality sign whenever you multiply or divide by a negative number on both sides of the inequality.